Hello everyone, today we're gonna learn about area and average. Firstly, let's review what we have learned in math class before. First of all, how to calculate the area of a square. We multiply x by x, which is x squared. It is the area of a square. Then, how do we calculate the area of a rectangle? The area of the rectangle is 1 times length. And how about triangles? It is x times height and divided by 2. Finally, the trapezoid. The area of the trapezoid is x plus y bracket and times the height and divided by 2.
First of all, let's do a test. We assume that the car is traveling in a positive direction at a constant velocity. The velocity of the car is 20 meters per second. From the test, we can get a velocity time graph like this. The velocity is 20 meters per second. Firstly, we are trying to find the displacement by using the formula delta d equals to the velocity times delta t. Now, we sub the numbers into the formula, so the velocity is 20 meters per second and the time is 20 seconds minus 5 seconds, which is 15 seconds. And the displacement is 300 meters. Now, let's calculate the area of the rectangle between the line of the graph and the time axis for the time interval of 5 seconds to 20 seconds. To calculate the area, we multiply length by width, which the length represents the time interval and the width represents the velocity of the car. So we got 20 seconds minus 5 seconds and multiply by 20 meters per second. Then we got 3 meters at the area. Therefore, the area in the velocity time graph represents the displacement the car traveled. Therefore, we can get over conclusion 1. You can find the displacement by calculating the area between the line and the x-axis. The sign of the area tells you the direction of motion. Now is another test we're going to do in our lesson. The test is based on the average of the velocity. The car travels in the positive direction with a constant velocity, and suddenly it changes its velocity to a smaller velocity and it keeps going away from the origin. Now let's calculate the area in the velocity to confirm either the area equals to the displacement or not. Firstly, we divide the area into two rectangles, which will be easier for us to calculate. So from the test, we can get the car travels fast at the beginning at a constant velocity. Then there is a kink at the time of their 0.4 second, which means the sudden change of the velocity. Then the car travels slower at a constant velocity. From the graph, we can get the velocity for the first interval is 100 centimeters per second, and the velocity for the second interval is 40 centimeters per second. From the position time graph, we can also get the velocity time graph. For the first traveling, we can calculate the velocity of the car is 100 centimeters per second, and the time interval is 0.4 second. For the second traveling, we can calculate the velocity of the car is 40 centimeters per second, and the time interval is 0.4 second. In addition, to connect the two different velocities, we need to draw a dashed line to indicate the sudden change. Now, let's calculate the area in the velocity to confirm either the area equals to the displacement or not. Firstly, we divide the area into two rectangles, which will be easier for us to calculate. So we have length 1, which is 100 centimeters per second, and we have length 2, which is 40 centimeters per second. Then we get width 1, which is 0.4 second, and width 2, which is 0.5 second. Next, we multiply length 1 by width 1 and multiply length 2 by width 2. Then add them together. The answer will be 60 centimeters. And let's go back to the position time graph. Then let's go back to the position time graph. We can say that the displacement is 70 centimeters minus 10 centimeters, which is 60 centimeters. Therefore, the area in the velocity time graph does represent the displacement. However, if the velocity changes while the object is moving, we may need to divide the area into several pieces to better calculate the area. We are going to work on the average velocity. We are going to calculate the average velocity by using arithmetic strategies. So we add velocity 1 and velocity 2 together and divided them by 2. Then we got a number which is 70 centimeters per second. Now we are using the average we calculated before to calculate the velocity. We have the area which is 60 centimeters, and we have the total interval which is 0.9 seconds. Then we can get the velocity which is around 66.7 centimeters per second.
And if we go back to the position time graph, we can make a line to represent the constant velocity of the car. If we calculate the slope, which will be rise over run, it is 6 centimeters divided by 0.9 second. That will be 66.7 centimeters per second, which is same as the calculation we just did. From the calculation we did above, we can find that the average velocities are not the same. The reason for that is because the average velocity means total displacement divided by total time interval, but not the average of several different velocities of different time intervals. There is a lesson for today. Hope you guys enjoyed it.